Okay, so the reciprocal trig functions, which are cosecant, secant, and cotangent, also have derivatives, and we can use the chain rule to derive them. So we think of cosecant. What is cosecant? 1 over sine x, right? Or you could say it's sine x to the negative 1. Not to be confused with sine inverse of x, right? But 1 over sine x. So if we want to do that derivative, what do we do? Well, negative 1 sine x to the negative 2. Okay, so that's the outer function times the derivative of the inner function, which is cosine of x. Which gives us negative cos x over sine squared x, which gives us, so we can split this out as negative 1 over sine x times cos x over sine x. So it's negative, okay, what's 1 over sine x? Cosecant x. And what is cos over sine? Cotangent x. So we have negative cosecant x cotangent x. Okay, so that is the derivative of cosecant. Write that out. Yeah, okay. So you try secant. Same kind of reasoning, right? And apply the chain rule. That. And we can do the same thing with cotan x. And cotan x, you could do as, what's cotan? Cos over sine and then use quotient, but we're not going to do that, right? We'll just do, yep. Negative? Negative. Right? So the negative 1 here, and the derivative of cosine is minus sine, 2 negatives. Okay, so same reasoning, right? This way. So equals negative. derive them all the time, but this is where they come from. Right? And you could do them all, of course. You could write cosecant as 1 over sine x and just use the quotient rule, right? You could write secant as 1 over cos x and use the quotient rule, and certainly with cotangent, you could write that as cos x over sine x and use the quotient. So in summary, right? So we're just going to fill this in, and you have those, right? I mean, they're on your formula sheet. So derivative of sine is cos. Derivative of cos is minus sine x. Derivative of tangent is secant squared x. Derivative of cosecant is minus cosecant x cotangent x. Derivative of secant is sec x tan x. And cotangent is minus cosecant squared x. All right, so all we want to do is play around with these. Do a few examples. So we've got 5 times the cotangent of 2 over theta. So I'm thinking, all right, well, so I got a, I've got a constant in here, right? So it's just 5 times d by d theta cotangent of 2 over theta. So that's going to be 5 times. All right, and the derivative of cotangent, should be sitting right above, on the line above, is minus cosecant squared. So it's going to be minus cosecant squared of whatever. In this case, the whatever is the 2 over theta, right, of something, times the derivative of that something, right? So what's the derivative of 2 over theta?
Negative 2 theta to the negative 2.
Negative 2 theta to the negative 2, yeah. Or negative 2 over theta squared. So if you want, let's go up here, a little piece of scratch paper here, right, and say, that's 2 theta to the negative 1, right? So the derivative of that, you know, is negative 1 times 2 theta to the negative 2, or negative 2 over theta squared. And so I think we got some numbers we can put together. So we've got the 5 and we've got the 2, and we've got 2 negatives. So that's just going to be positive. Okay. So when we clean it up, we've got 5 negative negatives. So that's going to be 10 over theta squared times cosecant squared of 2 over theta. And I don't really think I need those outer brackets, right? Just go cosecant squared of 2 over theta.
Is that the book that I could slip?
Yeah, you can have it. It's not actually a booklet, but if you want to staple in it, Peter will be happy to put one in it for you.
Thanks.
No worries. All right, what's next? Cosecant squared of 3x minus 4. And I got to switch sheets, right? Things change. All right, so we want the derivative of a cosecant squared. So I kind of sometimes just like to write this out as d by dx cosecant of 3x minus 4 quantity squared, which reminds me then that I'm doing the chain rule, right? So it's going to be 2 times, and then whatever the expression is in there, right? So cosecant of 3x minus 4, and that'll be to the power of 1. Okay, so we're just going to leave that. Times, and now we need the derivative of the inner, which is the cosecant of 3x minus 4. And the derivative of cosecant is your sheet somewhere, or down on my sheet somewhere. Cosecant. Minus cosecant cotangent. Okay, so we've got minus cosecant 3x minus 4 times cotangent 3x minus 4 times 3. So yeah, we got to go to the inside function now, which is the 3x minus 4. So times 3. All right, so we want to put that all together. What have we got? Well, it's all just multiplied together, right? So we've got a 2 and a negative and a 3. So that'll be negative 6. Take one of those. Negative 6. We got this times this, which will be cosecant squared of 3x minus 4. And then we've got a cotangent of 3x minus 4. Okay, questions? Good? Lovely. Okay, so this is going to be implicit differentiation, right? So to do implicit differentiation, we do the derivative with respect to x of each of the 3 terms, right? So we got cotan 2x plus y minus sine x and 3y. So we do the derivative with respect to x of each of those. Okay, so I'm not going to write y prime equals. As much as I want to write y prime equals, that's kind of a final step. So we're just going to do the derivative of cotangent, which is, what's the derivative of cotangent? Minus cosecant squared. Okay, so we'll get negative cosecant squared of 2x plus y. That's the derivative of the outer function times the derivative of the inner, so we need the derivative of 2x plus y, which is going to be
2y prime.
2
plus y.
Yeah, 2 plus y prime, right? So times 2 plus y prime. Minus, derivative of sine is cosine, so it's just going to be minus cos x, right? Had that been a cos x, we'd be writing plus sine x, right? It'd be minus a minus. Equals 3y prime. Okay. We got to expand that left expression, right? Then collect our y primes on one side, and then factor out a y prime, and then divide, and we're done. Okay, so really it's just algebraic manipulation at this point, right? So I've got this thing, so I'm going to get minus 2 times, right? So this times 2, minus 2 cosecant squared of 2x plus y. Okay, now another minus, so minus y prime times, do you want the y prime in the front or at the end? Doesn't make a difference, right? Yeah, okay. So
No, because that's like the inside of the cosecant squared. Oh.
that's one term, right? So it's this times this plus, well, okay, minus the y prime times this, which is cosecant squared of 2x plus y minus cos x is equal to 3y prime. All right, we can now take the y prime, yeah.
Shouldn't it be negative cosecant squared
Shouldn't who be negative, or which?
in the second? Yeah.
There's a negative there.
Oh. But like when you substitute it in, then you have to put it in negative cosecant squared.
Well, I'm multiplying this times y prime.
Okay.
So negative y prime cosecant squared 2x plus y. Okay. So let's move that over. So we've got minus 2 cosecant squared of 2x plus y minus cos x is equal to 3y prime plus y prime times cosecant squared of 2x plus 1. So we're going to factor out the y prime. We're going to get minus 2 cosecant squared of 2x plus y minus cosine of x is equal to y prime 3 plus cosecant squared 2x plus y. So y prime is equal to what I've got on the left divided by this set of brackets here. So a lot of times they'll take out a minus sign. So I might write the minus up here. We could choose to or not, so we could just write it as minus 2. Minus 2 cosecant, oops. Cosecant squared of 2x plus 1 minus cos x over 3 plus that. Okay. I don't think we're doing anything further with it, right? Nope. So the only thing we might see a bit different is they put a negative sign and then put brackets around the 2 cosecant squared and put a plus cos x. You could move it, yeah. It's kind of awkward. So if the bottom was 3 minus cosecant squared, then I would just flip the signs on the bottom, right? And take that negative out of the top and move it to the bottom, and then just write it as this plus this or this minus this. That's all just variations, right? So especially when you're doing, a multiple, and this really isn't a multiple choice question, right? I mean, there's a bit too much work involved in that. So, it's something you're pretty much having to work out. All right, we good? Yeah, what is that, right? I mean, it's the slope of the tangent to the thing at some point, xy, which... Oh, y double prime, yay. If y is equal to secant 2x. So where do we start? I guess we're going to start with y prime. And what's the derivative of secant? Sec x tan x. So y prime is going to be the secant of 2x times the tangent of 2x and what else? Multiplied by 2. Okay, so okay if I just throw the 2 in the front? Yeah. Okay. It's really kind of at the end, because it's the derivative of the 2x, but it's got to end up at the front. Okay. Now we want y double prime. Well, it's going to be 2 times, and then the derivative of sec 2x tan 2x. And we already know the derivative of sec 2x, right? We just did that. So we're just going to take what we have there and copy it right here, right? Because we want the derivative, oh, sorry, not yet, right? We want secant 2x, sorry, order. We need the derivative of tangent. What's tan? Secant squared? Derivative of tan is secant squared, right? Yeah, okay. So we got secant squared 2x and? Times 2, right? Because we've got the inner function, the 2x. Times 2. All right, let's put that there. Plus, okay, now we want tan 2x times the derivative of secant 2x, which we have on this line here, right? So, you can redo it or not. So it's 2 secant 2x tan 2x. Okay, now it just requires cleaning and polishing. All right, what do we got here? 2 secant cubed 2x plus 2 secant 2x tan squared 2x. So looking in the brackets, I say, hey, I can pull out a 2 secant x, right, as a common factor. So if we pull out a 2 secant x, we got 2 here, times 2 will be 4 secant of 2x. And then here, we got the 2 out of here, so it's secant squared 2x plus tan squared 2x. Now tan squared, somewhere on your formula sheet, I think what's tan squared equal to? Like c squared plus 1 or 1 plus secant squared? Is that on? Tan squared is secant squared minus 1. Okay, so then we could write this as, so we got a sec squared 2x plus sec squared 2x minus 1. Right? So that's just using the tangent squared is secant squared minus 1. And so what do we get? 4 times the secant of 2x. So we got 2 of these guys, 2 secant squared 2x minus 1. Okay, again, just alternate forms, right? So you end up with the third line from the bottom, and you're looking to find that, and you don't see it anywhere, right? But you see a secant squared. So you say, I don't see a tan squared, I see a secant squared. What's that relation? What do I do? Okay, replace that. Alternatively, what's secant squared then? 1 plus tan squared? Secant squared.
Yeah.
Yeah? So then maybe you see, what, 2 tan squared plus 1 or something? All right. Next. You go to determine determine the equation of the tangent line to the curve y equals 4 plus cotan x minus 2 cosecant x at x equals pi over 2. First step is to do what? Figure out y prime, right? That's the expression for the slope. Then we'll evaluate y prime at pi over 2, find the slope of the line at that point. Then we got to stick the pi over 2 into the y equals to find the y coordinate of the point, and then we'll use that xy, the point, with the slope to get the equation of the tangent line. But, one thing at a time. So step 1, y prime. All right, somewhere I wrote down something. That's our extra worksheet. Okay, so it's the derivative of 4. 0. Cotangent is, what the hell is cotangent? Negative cosecant squared. Okay, so negative of x. And the derivative of cosecant is, what's that one? Cosecant cotangent? Negative cosecant cotangent. Okay, so it's going to be that'll be a plus 2 cosecant cotangent. Okay, so let's just rearrange. So let's go with the positive. So 2 cosecant cotangent minus cosecant squared of x. All right, so we want y prime at pi over 2, right? When x is pi over 2. So now we're going to substitute. So y prime x is equal to pi over 2. So it's 2 cosecant pi over 2 cotangent pi over 2 minus cosecant squared pi over 2. Okay, what's the cosecant of pi over 2? It's cosecant. It's reciprocal of sine. Sine of pi over 2 is, I think that's a 1, right? 1. That's a 1. Cotangent of pi over 2.
0.
Would be 0, wouldn't it be? 0. Minus. Well, we had to work out cosecant anyways, right? So that's a good thing. I mean, we didn't waste doing, because, you know, everybody said. So what do we say? Cosecant is 1, so it's going to be minus 1 squared. Okay, so what do we end up with? Negative 1. Okay, so the slope of the line we want is -1. And now we need a point on the curve. So point on the curve is y is equal to 4 plus cotan pi over 2 minus 2 cosecant pi over 2. We just figured all those out, right? So it's nice. I'm wasting any time. So 4 plus, okay, when we say cotan of pi over 2 is 0, so 4 plus 0 minus 2, and cosecant of pi over 2 is 1. So 4 minus 2 is 2. Okay, so the slope is -1, and the point is pi over 2 and 2. So using your favorite formula for the equation of a line, I'm point slope. Y minus 2 is -1, x minus pi over 2. And we just, buff it up and make it presentable to be seen in public. So 2y minus 4 is -2x plus pi. All right, we got a 2x plus a 2y minus a 4 minus a pi. And that's equal to 0. See anything, let me know if you see anything. The sooner the better. It's always good instead of like, oh, 3 pages ago, shouldn't that have been a -1?
Yeah,
Or
it
whatever.
should
Yeah. Sometimes these things will go on for an entire page, right? And so you really do want to, if there is something, please point it out sooner rather than later. The curve of y equals blah has a horizontal tangent point or tangent line at the point AB where A is between 0 and pi over 2. Determine the values of A and B. Okay, so horizontal tangent point means what? Slope is equal to 0, right? Okay, so that means that y prime is equal to 0. And we've got a y prime expression here, right? So was it 2 cosecant cotangent minus cosecant squared? 2 cosecant cotangent. And whenever I say cosecant cotangent, I really mean the cosecant of x or the cosecant of something. I sort of say it. All right, so well, we could factor out a cosecant, right? So it's cosecant x, and that gives us 2 cotangent x minus cosecant x equals 0. So we could say, well, the cosecant is 0. When does that happen? It's like never, right? Remember your secant, cosecant graphs? No, they don't hit 0, right? They're from 1 up and from -1 down. Okay, so that means that 2 cotangent minus cosecant must equal 0. What's cotangent? So 2 cos x over sine x minus 1 over cos x is 0. So we need a common denominator. Well, actually, we can multiply everything by sine x cos x, right? That'd be the easiest way. Multiply through by sine x cos x, giving us 2 cos squared x minus sine x is equal to 0. Oh, no, wait, what? 2 cos x minus... Oh, sorry. Cosecant is 1 over sine, not 1 over cos. Supposed to point that out. Okay, better. Multiply through by sine x. We get 2 cos squared. No, we get 2 cos x. Wow. 2 cos x minus y is 0. 2 cos x is 1. Cos x is 1/2. And we're only looking from 0 to pi over 2. So when is cos a half? Pi over 3 or something.
Yep.
Okay, so then x is equal to pi over 3. So x is equal to a, right? I mean, the point is AB, so we've got the pi over 3. And now we want the y value. So we're going to plug pi over 3 into here. So y is equal to 4 plus cotan pi over 3 minus 2 cosecant pi over 3. Oh, wow. Okay. Cotan of pi over 3. What's the tangent of pi over 3? What is it? Tangent root 3 over 1? Root 3 over 3? Well, let's call it, that's 1 over root 3, right? Because we're going to flip it. So then it would be root 3. Would cotan of pi over 3 be root 3? Or no? Yeah? Root 3? All right. 4 plus root 3. And cosecant. Cosecant is 1 over sine. Right? Yeah, 1 over sine. What's the sine of pi over 3? It's root 3 over 2. So it would be 2 root 3 over 3. So minus 4. Okay, so minus 2 times, what did you say? It was 2 over root 3? All right, so we need a common denominator. Or, well, okay, we could rationalize this, I guess. So why don't we call this 4 root 3 over 3? Let's call this 12 plus 3 root 3 minus 4 root 3 over 3. Just going common denominator of 3, which will be 12 minus root 3 over 3. I'm not convinced. I have a different answer written down, so I don't know if I got just 4 minus root 3. All right. Did we do the cotan of pi over 3? All right. Hang on. So what's cotan? It's cos over sine, right? So it's cos pi over 3 over sine. Cos of pi over 3 is a half, and this is root 3 over 2, so it's a half times 2 over root 3.
It's supposed to be root 3 over 3.
Yeah, this is root 3 over 3. Okay, so then that doesn't need to be multiplied. Okay, so what do we got? 12 minus root 3, no, minus 3 root 3 over 3, which is 4 minus root 3. There we go. Okay, so the point is pi over 3 and then 4 minus root 3. Wow, tripped up by cotangent. All right, let's move on. Determine the equation of the tangent curve to y equals sec x cosecant 2x at x equals pi over 12. Okay, so need y prime, right? And where's my secant? Or do I have something down somewhere on some page? Here, here, here. No. Hey, is this the last one?
Yeah.
Oh, thank God. Okay. Yeah. I don't think I have it written anywhere. All right, so we're just hitting this up from scratch. All right. So let's do this derivative. What's the derivative of secant? Sec x. Sec 2x. Secant x tan x. Tan 2x times 2. Oh, no, wait. It's a product, right? So it's secant 2x times the derivative of cosecant. So what's the derivative of cosecant? Minus cosecant 2x cotangent 2x times 2 plus cosecant 2x times the derivative of secant, which is sec 2x. Okay, so far so good? So it's f of x times g prime of x plus g of x times f prime of x. Okay, so what do we got in common? We got a cosecant, right? And we got a 2. And we got a secant. So we got a 2 and a secant, a cosecant. And let's do the plus 1 first and the minus 1 second. Okay, so 2, we got a secant and a cosecant. Don't. Why am I doing that? Times, okay, so we got that, so it'll be a tan 2x minus cotan 2x. Okay, does that look good? Hey, don't just get out the eraser. You make sure somebody messed up. It might not have been you. We have general agreement? Sure. Okay. So we want that at pi, oh God, pi over 12. Oh, but they're all 2x's. Thank God. Okay, so we want that at pi over 12, right? I mean, there's no point worrying about any further simplification. So x equals pi over 12. So it's 2 secant pi over 6, cosecant pi over 6, tangent minus cotangent. Okay, what are the odds? Secant is 1 over cos. Cos of pi over 6 is root 3 over 2. So 2 cosecant is sine. So it's sine 2 over 1. Tangent. Tangent is sine over cos. That's 1 over root 3. Okay, check those over. I don't have a good track record so far. Getting them right.
I don't remember the unit circle.
Well, you might have to go look at it again. Okay, well, if you agree.
Let's go with that.
Well, let's see, can I just write that over root 3? So think I can do that, right? Yeah, 3 root 3. All right, that's what I've got. And we need the, if you disagree, feel free to. I mean, so the point at x equals pi over 12, so secant pi over 6 times cosecant pi over 6. I think we already worked those out, right? That'll be 4 over root 3. So 4 root 3 over 3. Multiply by 12. Oh wait, let's clean it up first. Negative. 36. What am I multiplying by? So that'll be 12 times 16, 160, 92. Whoa. Done. Okay, let's pause this. Scroll up. What's pi divided by 12?
A number.
Yeah.
0.26179938878.
0.26.
Sure.
All right.
Could have told me you only needed 2 decimals.
Well, I think that would have been sufficient. So.
Oh, so you need it to 3.
All right. 0.26.
0.262. If we're rounding to 3. Was that so hard?
So that puts it about there, which is not unreasonable, I don't think. I mean, it's not showing us the point of intersection. You know, often it shows us that point of intersection of the two curves, but this time, but it seems reasonable. So we'll leave it there.